All right. Good evening, everybody. Good to see you guys. Welcome to the last week of AP Stats. Those of you that already took some AP exams, hopefully everything's gone as smoothly as it can for you. I know there were some struggles with uploading and whatever else, but I know that there's some added, I guess, backups this week with the email and everything. So by the time Friday rolls around, we'll all be experts at it. I'm really looking forward to tonight. Feel free to say hello in the chat. Share any, if you've taken any exams, how have they gone so far? How are you feeling about Friday? Whatever else, because we are going to do a live practice test tonight. So I'm planning on spending the hour doing some real questions that I've created just for us, and then going through some rubrics that I've created to go with them. So that is that. We know the big picture, so I'm going to skip over that and just kind of reminder about, hey, we are at the end of our solo sessions that are just Cram sessions. On Thursday, there will be the Cram finale. You guys all already have access to it. When you do click on that event, it might ask you to pay $5. Don't. Just make sure you've signed into Crowdcast on that tab, and you should get free access to it. I will be there with another streamer named Bob. We've been chatting a lot the last few days to make sure the experience is good. And it's going to end up looking, I can give you a little bit of a sneak peek. We're going to try to go through each unit one at a time for about 30 minutes, doing some quick hit review of some topics. And then here's a couple of scenarios to look at. And then the last hour or so, I'll do a couple of mixed problems and make predictions for what kind of questions we're going to get. So that is on Thursday. I really hope that you guys choose to come to some or all of that. And I am curious from my folks who have been to other 5-hour streams, if you do have any kind of suggestions, please send them my way. I'll admit I have not been watching other subjects. So I am more than willing to try to make it as good an experience for y'all as we can and hopefully learn from what's gone on in the past. So tonight, okay, 2 problems. Okay, I've tried to make them so that problem 1 would take about 25 minutes. Problem 2 will take about 15 minutes. It's going to be give or take a couple minutes there. It's possible that you finish problem 1 kind of quick. It's also possible that you don't finish them, and that's okay. I want you to practice as if it is Friday. And I will have the link ready to go in just a moment here. I want to set some ground rules before we start. Because I want people to actually do this as a practice test, I'm going to ask that we don't put answers into the chat until it's actually time to review the rubric. At which point, if you've used a Google Doc and you've typed stuff out, you can absolutely copy paste stuff over. Or if you've written stuff on paper, you can try to follow along as best you can. Or if you do want specific feedback on yours, you can type those in there. But I am going to ask that you try to refrain from putting answers into the chat as we go. Okay, and so without further ado, okay, I'm going to put the link to the first question into the chat box. I only have the second one up, so give me just a moment here. Here is problem 1. Get shareable link. That's the one. And I'm coming back here. I'm going to put this in here. This should be a link to a PDF. Okay, please give a little thumbs up emoji or a yes, I've got it, or whatever else once I know that it's there. I'm purposely only giving you question 1 right now because I want you to have the 25 minutes to do that, and then we'll do it. All right, so with that, okay, I am going to hit play on this timer. When there are 5 minutes left, I'll give you a kind of a 5-minute verbal warning. And then if people are super done at that point, we'll move into the answer part. But if people need all 25 minutes, we'll do it. So guys, good luck. I will see you at about 9:30. We are at 5 minutes remaining. 5 minutes to work on this problem, and then we will come back together and I will stop making all these noises. Hopefully my computer settles down a little bit. Brandon, you always have such interesting ideas. Gonna let people just kind of not this time. All right, 2.5 minutes left. For those of you that have wrapped up, if you have finished, I've put a poll down here in Crowdcast where you can kind of give a little bit of a rating. We'll get to that. We'll talk. 2 minutes. Mm-hmm. Ooh, that's a fun timer. All right, y'all. Proverbial pencils down. Banner ad gone. We're gonna pause that. Come on back if you have not answered the polls. Feel free to give a response there. I'll give a minute or so for people to just kind of decompress. You can start throwing stuff in the chat now. If you would like to put your responses there, you can. But what I'm going to do is go through the rubrics in just a second with kind of how I envision the scoring guidelines for this kind of question would go based on past questions similar to this. So I'm not trying to pull things out of thin air here. I'm trying to use my experience to go through previous exams and come up with stuff that I think could be reasonable to ask this year. So let's go ahead and get started. So you just did the scenario involving an experiment with eggs, where we're going to see if the temperature you store them at affects their freshness over time, and then got into some two-sample t-testing. So jumping right in, part A asked you to identify the experimental units, the treatments, and response variable. Yeah, you can definitely copy and paste into the chat if you'd like. I'm probably not going to pull up like Harrison. I appreciate that you've linked to it, Google Doc. It's going to be too many screens for me to go through. So I'll give 30 seconds or so for folks to copy paste if you'd like. Anusha, it's your call. I will say, I mean, my students are invested in writing because they're nervous about symbols. Anytime they want to write a symbol, they don't know how to type it. So, but I think this year is going to be much more written than it will be notational. So I think there's a pro and con there. There is a pro and a con. Okay. All right. So experimental units, they are the containers of eggs. Containers of eggs. Experimental units are the smallest group of individuals to which you apply a treatment. You are not giving each egg a treatment. You're giving each container a treatment by putting them in the fridge. So I based this. There was a very similar question last year about insects. I know some of you have definitely done that one because we've talked about it before. So it's unfortunate. The treatments were the storage temperatures. So your answer would need to either list the 3 different temperatures in degrees, or just say the different storage temperatures, something like that. And then the response variable, this is another one that was like, ooh, this was kind of mean. Okay. It was not the freshness rating, it was the mean freshness rating of each container. Each egg got rated and then the result for the container. So the thing to understand here is your response variable has to be consistent with the experimental units. Like you need to be measuring something about those units in the experiment. Okay, so you're not going to be measuring a response variable for each individual egg. It's going to be the container of eggs that gets measured. Parts C, D, E, and F, we start to do an analysis of each individual egg, but that doesn't come until later. Leah, if you just say temps, that should be fine. If you just say the temperatures, that should be okay. So just freshness rating, I'm going to have a hard time with that, to be honest. So last year, the similar problem was it was about the number of dead insects in each container at the end of the week. And you just saying dead insects didn't count. Just saying number of dead insects didn't count. It had to be clear that it was the number of dead insects in each container that counted. But I think for this, my guess is freshness rating would probably be counted. But I think to be most precise, it is the average freshness for the container. James, the reason why it was containers is the treatments, whatever you're applying the treatment to is the experimental unit, but you're not taking each egg and putting it in a temperature. You're putting the eggs in cartons and putting the cartons in the temperatures. So it's the cartons getting it. So it's an analogy of like fish versus fish tanks. You're not giving each individual fish different food. You're giving the tank the food, and all the fish in the tank get that food. So in this case, obviously, if you get all 3 right, that's going to be E. 2 parts described is going to be a P. So my guess is if you said like something like the experimental units are eggs, the treatments are the different temperatures, and the response variable is the freshness of the eggs, that should count as partial because I think the response variable would then connect to your experimental unit that you defined. Yeah, so the technical definition, so we often think experimental units are who is in the experiment, but when the experiment is about things that aren't human, it gets a little trickier. So Jeffrey said, yes, whatever we're imposing the treatment on is the experimental unit. It's the smallest group to which you're applying the treatments. And in this case, we weren't taking each egg and randomly assigning it to a temperature. We were putting the eggs in containers and then assigning each container to the different temperatures. And so it's the groups of dozen eggs that are getting assigned. And so that's what the experimental unit is. In past AP exams, they've done scenarios involving fish and you had to make it clear that it was the fish tanks receiving the treatments, not the individual fish. And last year it was insects in these little containers getting sprayed with fungus. So just they've done little tricky things like that before. One year there was an experiment and the units were just birds, and every bird got put in its own cage. So that doesn't mean every time they ask you for experimental units, it's this trick curveball question. Just be aware that it could be. Okay, so that's part A. Part B then builds off of that. And so you had to describe a process by which treatments can be randomly assigned to the experimental units. I'll let you guys kind of evaluate your own answers here. But really, you needed to assign each container a unique number or label. So like writing 30 numbers on pieces of paper or giving each container number 1 through 30. You then had to describe some kind of random process involving random selection of those labels. So if you did the hat method, you'd have to shake up the hat before you pick the paper. Random number generator, of course, you would say that you're picking numbers between 1 and 30. And then you also have to name which treatments are going to which group. Okay. I will add the caveat here that if you said eggs as the units in part A and then consistently describe giving each egg a number and assigning each egg to a container, that can count, but your numbers would have to shift from 1 to 30 instead of 1 to 360. If you do the hat, you don't have to necessarily do replacement, but you have to make it clear that you're only going to use each slip once. So if you do with replacement, you have to make it clear that you are not going to let repeated numbers come up. So it's actually safer to just pick the first 10. Those 10 numbers get assigned to 5 degrees, then pick another 10. Those 10 get assigned to 15 degrees, and the last 10 get your remaining treatment. Kate, if you're referring to part A, then yes. But if your answer in part A used eggs and then you used eggs here again, you'd be eligible for fully correct E in this answer as long as you did numbers 1 through 360 for the eggs. If you answered containers in part A and then didn't do containers in part B, that's a problem. So you had to have a consistent experimental unit here. You can do numbers in a hat. That one year they got around that by saying the administrator has a computer available. Describe how to use the computer to do this, and you had to make it random number generation. But every other time it's been simple random sample or random assignment, you can do the numbers in a hat. If you don't mention without replacement, I'd have to see how you wrote it out. If it's very heavily implied that you are choosing the slips of paper out of the hat, that is generally seen as done without replacement and can be implied. So I don't know if you need to explicitly do that, but if you explicitly describe a process that is with replacement and don't make it clear that you're skipping repeats like you would if you were doing a random number generator, so you have to say unique numbers or skipping repeated numbers or that kind of thing, that's where you run yourself into trouble. But the names in a hat, the key thing is mixing, having very explicit mixing going on. All right. So that is parts A and B. That is our nice collecting data questions, describing things about experiments and then doing a assignment procedure, which could be very similarly done with a random selection procedure. All right, part C is where we started to get into the cussing, as people like to sometimes call it. You had to write a few sentences comparing the distribution of ratings. This should have been a pretty straightforward one. You got to name the shape. I would go skewed left for the 5-degree group, and the 25-degree group is approximately symmetric. Okay, you need to compare the center. You have all the data available to you because it's a discrete histogram with single-digit intervals. So you could have found the means. That's totally fine. You could have found the medians as well. Okay, but you need to, again, make sure that you're comparing. So just reporting is no good. You can just say center. Center is okay. Generally speaking, that's fine, because both measures of center were the same. 5 degrees center was greater than 25 degrees center. So like I'm seeing a couple answers come in. Kate, you name the mean for both groups, but don't name which group is larger. Okay, comparisons must include comparison words. So Brandon mentioned the median rating of 6 in the 5-degree group is greater than the median rating of 25-degree group of 5. That's going to count. Could you say peak instead of median or mean? No, you cannot say peak. Peak is not a measure of center. That is going to be valid. Measures of center that are valid are mean and median. I thought we could only use the median. The median is definitely recommended, but given the fact that on this histogram, you can see how many 1s were assigned, 2s assigned, 3s assigned, 4s assigned, you could, it would be a long process, but you could find the mean for this. It's a more fair comparison to find the median, but it's not a required comparison. Leah, you do not need to give the exact values in comparisons. That's a good question. Comparing the spread, the ranges are the same. So if you went out of your way to do standard deviation, good for you. There's a slightly higher standard deviation for the 25-degree group, but the range is the same. And then your answer's got to be in context. Okay, so every answer I've seen so far has been in context. You've been talking about this degree group versus that degree group. You've mentioned the eggs. You've mentioned the ratings. All of those keep your answers in context. If you do all 4 of those things, you're good to go. You've got an E. If you did 2 or 3 of them, you get P. So a lot of times with the compare distributions, you actually have a lot of wiggle room to get partial credit. But again, look carefully. You have to have the comparisons. The comparisons are really, really key. All right, keeping it moving. So we did collecting data, that was describing data, and now into analyzing it with some hypothesis testing. Okay, so the researchers intended to conduct a 2-sample t-test. You were asked to state the conditions and verify they've been met, and then write appropriate null and alternative hypotheses. What's nice about this is we've already defined the parameter in the question, mean rating between coldest and warmest. Okay, so you needed to check the random assignment condition by naming the fact that the containers are randomly assigned. You needed to check the normal condition because both groups have 120 eggs, and that's greater than 30. Yes, I need to see greater than 30. I need to see greater than 30. Then in the next part, your null hypothesis has to have, can you say n equals 30? It would be, Bella, it'd be better to do something like this that I'm going to type here, where you label the sample size and explicitly compare it to 30. Yeah, that should be fine. The null hypothesis has to make it clear that there's something equal or no difference. And the alternative has to make it clear that it's a 2-sided test. It's not a less than, not a greater than. It specifically said if there is a significant difference, but didn't specify what that difference was. Okay. And then your hypotheses have to clearly refer to population parameters. We didn't have to, in this, I'm not going to make it a requirement on the rubric to separately define the parameter because we're naming in the prompt what parameter you're doing, the mean rating. So as long as you've got symbols like mu 25 and mu 5, that's fine. COVID's got a good question. What about 10%? The 10% condition was not appropriate to check in this case. It's because, as Harrison said, this was an experiment. The 10% condition is only for scenarios involving random selection without replacement. So, Allison, in past years with this, it's been seen as an extraneous thing. we didn't have random sampling. The eggs that were drawn that day are not clearly labeled as a random selection of eggs from that day. So if it was, then you would need to make it clear that it was random sample. But in an experiment, the random assignment takes care of your independence because the groups are now totally separate treatment groups, and we don't have to worry about the independence of the groups. I hope I just literally answered your question as you were typing that. Random assignment of treatments is what creates independent groups and satisfies the independence condition in this case. Yep, any condition. So there's only ever up to 3 conditions. Random, and then if it's a 2-sample test, independent random samples. Random assignment takes care of the independent random samples. Normal condition, which is your large count. So the z-test, it's at least 10 successes, at least 10 failures. T-test, it's at least 30 in each group, or an approximately symmetric graph if you're less than 30. And then if you did random sampling, the 10% condition. If you didn't do random sampling, you only need those first 2, random and normal. Some people call it RN10 are the 3 conditions to check. Not to worry. Random, normal, always got to check. The random comes from random selection or random assignment. Normal comes from your large samples. The 10 or the 30 is the magic numbers. And then the 10% condition for the independence of your random sample is only if you took a random sample. In an experiment, don't need it. Okay, so Bella, you should define the parameters, but I have seen different rubrics from different years where in a situation like this, where the parameter has been defined a few times throughout the problem, you don't need to write a separate statement for it, but it's never a bad idea. And if I were to include it here, it would make it go to 5 components for scoring, and then the partial would be 3 or 4 of those components. Okay, so we've done conditions. 2-sample, that's for Z procedures. That's for Z procedures. So for proportions. Okay, this is where it gets tricky. The test statistic was T equals 2.484. I know that because I did it on my calculator today. With a p-value of 0.0137, explain the meaning. So Leah says we can expect that 1.37% of the samples comparing the difference of freshness between 5-degree eggs and 25-degree eggs at the given chicken farm will produce results as extreme or larger due to natural sampling variation. That is a great response, and it is unfortunately going to get partial credit because Leah has the phrase involving probability. The chance of, she says, so you say 1.3% of the samples is equivalent to mentioning probability. And you mentioned that the difference is as large as, you say, as extreme or larger. But you don't mention that this is under the assumption that the null hypothesis is true. Everything we do in a hypothesis test, all the calculations are conditional calculations, conditional on the fact that the null hypothesis is true. So if there is no real difference in the ratings of eggs, or in the freshness of eggs, or in the whatever you want to describe it, if there's going to be no difference in ratings from these eggs, then there's only a 1.37% chance that we would have observed a difference this large just by chance. Yeah, so Harrison, that will work. Okay. Context of the problem has to be in some way, shape, or form. You mentioned freshness, eggs, difference in ratings, that kind of thing. And if you do both of those, or all 3 of those, you get full credit. So Leah, having done the first and the third, is going to get partial credit. There are templates for how to write about p-values in a lot of textbooks, and we're going to make sure that's on the Cram sheet that you guys get this week with these components, where you have to mention it's a observed difference as large as the one you observe or larger, assuming that the null hypothesis is true. And then the one that's a little more straightforward that I think we're all going to do well on is, what conclusion do you make? Okay, there's always 3 things we look for when we're checking the conclusion you make. Do you compare the p-value to 0.05? You have to explicitly compare it. Do you then make the correct decision about HO, which in this case is a reject? And then do you state your conclusion, your evidence in context. There is a difference. So Lydia, because the p-value is lower than the alpha level of 0.05, we reject the null hypothesis. Therefore, we have convincing evidence there's a significant difference in freshness based on storage temperature. Shine from the heavens. Hooray, hooray. That is going to do all three things. I added a little bit in this case to spice it up is what type of error might we have made? Well, we might have made a type 1 error because type 1 error is when we reject HO when we shouldn't. And so if we reject HO, we're open to a type 1 error. You would not need to elaborate in this case just because it said what type of error may have been made. It did not say and explain a possible consequence of that error or something like that. It's never a bad idea to talk more about it. But if you said, like if you gave the full description and then said, this could have been a type 1 error, that's fine. Because that shows your understanding of what a type 1 error is. Although now that I'm talking about it out loud, I'm realizing that then gives you a 50-50 shot of getting it right. So you probably might need to say, this could be a type 1 error in which we would reject a null hypothesis by mistake or something like that. Yeah, I like what Harrison did at the end of his. Type 1 error could have occurred if there was actually no difference in the freshness of eggs at different temperatures. Okay, and so all four different than 0. Yeah, Anusha, that's great. Your response does all three of the first things. This question I tacked on a little extra bit about what type of error it could be. So on this rubric that I just created, you would have gotten partial. My guess is, to be honest, is on Friday, the question that you interpret a p-value on, and I am as sure as I can be that one part of one question is going to be what conclusion should you make from a p-value, and you should just do those three things and you're going to be golden. And so, not to worry. That brings us to the end of question 1. How are we feeling so far? Are we feeling excellent? Did that crack your brain cells at all? Are you sick and tired of these yolks that I'm making? Other egg puns? I don't really know. Got others. Because if not, we are ready for question 2, which is the shorter one. Yeah, I'm throwing it back all the way. Oh, thank you. Oh yeah, we're back to the egg puns from Units 2 stream. You know, I got a good memory for these things. All right. So all that just for the record, yeah, there's a bunch of egg ones, and then the other one that we've seen like 3 times is blood pressure. Like, blood pressure is the thing they ask about. There's some teachers that are talking about they think it's because blood pressure feels like something there's, you know, a neutral thing you can talk about the human body, where like they don't want to talk about people's weight, they don't want to talk about people's heights because people might get sensitive, but blood pressure is okay, whatever, I don't know. So with that is the end of question 1. All that typing you heard, full disclosure, just like sometimes, you know, you guys as students don't always have everything all the way prepared as you should when things start. I was, you know, maybe sort of kind of doing the rubric for question 2 while you guys were doing question 1. Maybe, who knows? So with that, I had to just X out of that. And oh, look, oh my God, here it is. Oh, everything's good with the world now. And the rubric's ready to go. So, oh, I don't want to stop. Okay, my apologies. All right, here we go. I'm about to drop the link for question 2 into the chat. Much shorter time frame this time. Okay, to give a quick couple people giving a little thumbs up would be helpful, just so I know that it works. And you should see a 2-way table. It's a scenario involving the public library. Fabulous. 15-minute timer begins now. See you guys at 10:09. Oh, wow. I can experience and embody Jesus. Oh, goodness. We got 5 minutes remaining. Wait. All right, we're wrapping it up. Proverbial pencils and or typing fingers down. We got to make it visible, I think. I've done another poll for question 2. You should be able to see it in the active polls. I don't have any library puns for this one, so couldn't go with it. If you have any library puns, feel free to put them down in the chat. Okay, Katie, I got to go through the rubrics now, so this is not gonna work. All right, so early returns are maybe not as great as question 1. Okay, let's take a look. Just for the sake of time, it is 10:10, so I do want to honor the fact that you guys are here past an hour. So I'm going to go through the rubric. I will stick around after going through the rubric to if I can answer any individual questions, but I do want to move relatively quickly just to acknowledge the fact that folks are staying a little late. So the first part, so you're given the setup, you're given the scenario about whether or not people support this new proposal for the library from a single sample of residents in the city. And yeah, let's check out these solutions. Hopefully there's nothing overdue. So in part A, you should have gotten no, okay? And then you needed to justify that no with appropriate probability calculations. So there's 2 ways you could have gone about it. You could have found the probability of being 55 and the probability of 55 given that you support, or you could have found the probability that you support and the probability that you support given that you're over 55. Whichever calculations you did, they got to be right, but neither of those resulted in matching probabilities, and therefore the answer is no, and your backup work is the probabilities that you calculated. So saying something like, because these probabilities are not the same, that means that knowing the outcome of one event has an impact on the other, therefore they're not independent. Or really you can just say like, since P55 plus not equal sign P55 plus given yes, these are not independent events. The definition of independence is known to be that definition, so you don't need to go out of your way to define it further. So if you did all 3 of those things, shout out to you. If you did not, ooh, no. Yeah, Lydia, I have to imagine that this is probably as intense as the probability questions are going to get, because anything that would require more than addition, multiplication, or division is probably not going to happen. Now, this division is doable, like that probability is okay. So this is about as deep as I think it can go with probability, if that answers your question. Yep, those aren't equal. Good, Anusha, that would count. Yeah, Harrison. Ooh, okay. So Harrison, you went the other way. You went for the multiplication idea. Your calculations are going to also support this. You'll be okay. That is, yeah, it's like that is a lot. Definitely don't need all those. Just in case you are wondering, traditionally on the AP exam with decimals, it's got to be up to the 1,000th place. Got to have 3. At least this is my calc teacher coming out, speaking about calculations. Got to have 3 decimal places. That is typically the cutoff there. But I think this year unsimplified fractions are going to be fine. That's my guess. All right, so then the city council wants to construct a 95% confidence interval to estimate P, the proportion of all city residents who would support the proposal. I wanted you to provide a point estimate for that confidence interval. And then I wanted you to interpret the meaning of the 95% confidence level in the context of this problem, not the confidence interval, the confidence level. So in this case, we should have done 25 out of 103 for your point estimate. You can leave it there. That's totally fine. If you then converted that into a decimal, I believe it was about 0.243 or about 242, somewhere around there, that would be fine. And that's, you showing that you understand that the statistic from a sample is the estimator for the population parameter. But most of the points are going to come in your interpretation. Okay, the confidence level interpretations typically need 3 things. Okay, you need to mention that you're doing this procedure in the long run or with repeated samples or using this method, something like that. Okay, and you need to include the fact that 95% of the intervals will capture a population parameter, and that parameter needs to be described in context. So Leah, in the long run, 95% of samples will produce an interval that contains the true proportion of city residents who support the proposal. Mwah. Textbook, well done. That's exactly how we would do it. It's got all three components. Okay, and so with that, you do all four of those, you're good. My guess for something like this would be to get partial. Any three of the components would be fine, but I don't think just two would count. I think you would have to do both of the correct, like the two would have to come from the description. I don't think you could get a partial by getting the point estimate and then just one part of the description right. I think you need two parts of the description right. I'm basing this off of a scenario a couple years ago where there was you had to find a point estimate, but then there was some more stuff involved. And a lot of people got the point estimate right and then didn't get the other parts right, and they didn't get any credit. You had to get something else besides the point estimate to get partial there. All right, Allison, you got to make it really clear what we're expecting for that 95%. 95% of what? So it's 95% of our intervals should contain the appropriate population parameter, or 95% of our intervals will contain whatever else. James, we're going to do the 95% sure that the real P is within the interval if they had given us boundaries. So this year, I don't expect us to have to do a calculation to get a confidence interval because, again, no calculator, but they might have given us a boundary. So I actually didn't do it for this. My guess is the P-hat was 24% and there was 100 people. So that's usually, the standard error is usually 0.05, I think. I don't know. It's the test is being designed as if you do not have access to a calculator. So any question that would require the use of a calculator is not going to be asked, which is why you've noticed a lot of these are much more about interpretation. So if they had given us those boundaries, let's say it was 0.19 to 0.28, then we'd say, oh, we are 95% confident that the true proportion of all city residents who would support the proposal is between 0.19 and 0.28. But in this case, we're interpreting confidence level. So difference between confidence level and confidence interval. Okay, moving on. I believe, oh, I just did the same slide twice. So hope that means I got another one. Yep, there we go. Okay, I believe that something like this is an example, Harrison, of what I was talking about, where you might have more parts than there are scoring opportunities. This could be a thing that would probably be scored together. Okay, because in part C, there's really only one answer. And in part D, there's really only one answer. So there's not a whole lot of nuance for us to get into when reading your responses. Okay. In part C, the reason that you need to have that condition met is that the sampling distribution is approximately normal. Okay. If you say the sample is approximately normal, nope, doesn't work. This is a categorical variable. You can't have normal distribution with percentages. Okay, you don't get the normal distribution until you have multiple samples, and then those p-hats become quantitative. And so sampling distribution is approximately normal. And then in part D, the answer is no, and we would need a justification because this data came from one single sample. Now, I was discussing this question with a colleague earlier today, and he was making the point, well, maybe could you make the point that because the people were separated by age after you took the sample, that they could be considered two independent samples, given that they were all collected from just one single sample. You really can't do two sample procedures when there's only one sample. You can do two sample procedures from one sample when you do an experiment and explicitly group the people based on your assignment. But when you're gathering data, it needs to be clear that they are independently selected samples from the population, and this wasn't. Okay, so I hope that's not an issue here. Yep, so approximately normal. Yep, and we especially like to say sampling with the ing at the end because they're different. I mean, it's it's a common misconception. So you do all three of those things, this kind of thing go together. So so to Harrison's question earlier, it's very possible that there could be, a parts A through H kind of thing on number one, but they might score some of those together. My hope is that they do not do that because they've made it clear that you might not finish all the parts. I don't think it would be fair to have multiple parts that have to be scored together. I should hope that each question is kind of its own ecosystem, so to speak, where you get your own question. Oh, buddy, you want to leave the room? Okay, we're gonna leave. A 2 sample Z interval will be incorrect because there needs to be 2 sample Z test. So an interval would be able to test a significant difference if you do a not equal to. So I think whoever just asked that, I'll stick around for a minute and explain it at the end. That's Lydia. So remind me to come back to that, because part E, last part. Okay, a proposal for a follow-up survey suggests using a stratified random sampling procedure, where an equal number of residents under 30, between 31 and 50, and over 50 are randomly selected about the proposal to expand the public library. Describe a statistical reason for conducting such a sampling method. Good news, you've got 2 options here. Okay, there are 2 statistical reasons why we do stratified samples. Okay, the stratified samples are there to ensure you get a representative sample, and I really should say, they're there to reduce the variability in the responses that you get. But you need to make it really clear that this would be done if there actually is a difference in opinions between the groups. That's why there would be a benefit. So you would want to make sure you say something like, it's important to ensure that all age groups are represented because the different age groups may have different opinions about the library. Okay, or something like that. Okay. So Leah says, since people in the same demographic, I want to say age range, I think demographics should count there, are assumed to have similar opinions about about expansion of the library, taking an SRS of each strata, the approval rating will be representative. That's going to work. Okay. If you do both of these things, you're good. If you do your first thing without making it like super contextual about the survey to the library, and you just generally say this will make a representative sample, or this will reduce the variability in the proportion, that's not quite enough to give full context here. You need to ensure that you're connecting it to why would these different groups feel different ways about the library. You don't even really have to give a reason why. You just have to suggest that they might, and then make it clear that that's why we'd be doing this. All right. Sample or sampling. So Allison, for part C, sampling distribution. For the approximately normal, it is the sampling distribution is approximately normal. Yeah. Yep, so Brandon takes it a step further by giving a possible reason why those people would have differences of opinions. He could have just said individuals in their specific age groups may have different responses, and then continued with his answer. Okay, and that brings us to the end of tonight. So big picture wise, okay, remember that the exam covers units 1 through 7 on here, and you really have 30 minutes to do question 1, but they suggest you spend that last 5 making sure you can upload, and you really have 20 minutes for question 2, but you should make sure you spend that last 5 uploading. So that's why I timed this for 25 and 15. I made sure that both questions hit multiple topics. If anything, my personal guess is I went a little bit light on units 1 and 4 and a little bit heavy on 6 and 7. But that's typically how exams go, is inference is a much heavier weight than the other stuff in the free response. But it's possible that there'd be a little bit less with the inference and a little bit more with maybe describing something about the data or making comparisons of the data. But I hope that I made for you a representative sample of questions. On Thursday's mega 5-hour stream, we're going to do a lot of released AP exam questions, not self-created ones, to show you examples of things from these units from the past. Yeah, 6.5 is based on the 55-45% breakdown. So 12-10 could be a thing. It could be a thing. What I have trouble with there, though, is because a lot of responses require multiple sentence answers, it just doesn't seem reasonable to me to have a 10-part question where you only have 15 minutes when one of those parts is going to be like checking conditions. Like that just doesn't seem like something that's going to happen. Ooh, Allison, be careful. There is no such thing as paired data with proportions. Paired data is only for quantitative variables with means. So you would probably get partial credit for that. You're like, because you state that no, we should do a one sample procedure, but then you add this extra information about paired data, which wouldn't count. Yeah, you can't really do paired data with that. So in terms of logistics, I'll answer a couple of questions, then we're going to kind of close out here. Yes, Allison, I think that would have worked, actually. I mean, we might need to strengthen it with a two sample procedure should have two independent samples and we only have one, and that would really close it out. No, you do not need to say that you should do a one sample. Yeah, no, you don't need to. Yeah, you're answering a yes or no question for that. It does not ask you to suggest an alternative. All right, so I'm going to stick around and do some more Q&A, but I want to kind of like, you can't do a one sample for a difference unless it's paired T. Paired T, you treat it as a one sample, but it's coming from two sets of data. All right, so folks, one last poll here. Just kind of curious on how you felt you did. How did you guys feel going through those, looking at kind of the responses and kind of judging your own answers? I recognize you might need a little bit more individual feedback on it. But if you found yourself getting mostly E's or an even mix of E's and P's, that is typically a recipe for a very good score. It's hard to predict because there's no multiple choice, so it's really hard to figure out kind of how the scale is going to go. But typically speaking, if you're able to get partial credit on every part, that typically results in you getting 2 out of 4 points on every free response question. And 2 out of 4 points on every free response question, coupled with about 50 to 60% of the multiple choice right, typically gets about a 4. And a 5 comes from getting a couple more E's and like 65% of the multiple choice right. If you find yourself getting like some P's and some E's and some I's, and you would get about half the multiple choice right, you're like pretty much guaranteed a 3 or higher. And so I know you guys are all obviously aiming for that. Hopefully you're aiming for a 5. But if you find yourself getting mostly E's, you can feel pretty confident that you're trending towards a high score. I can't guarantee, of course. We can never be 100% confident in statistics. You guys know that. But I'm grateful for your participation. I hope that felt like good practice. And what did I just do to my screen? I genuinely don't know. Okay. And so with that, I want to say thank you guys for everything that you have done throughout these last 8 weeks now. I hope that you feel like you're better prepared. And please, hey, all the things you're saying to me, if you are given surveys, I'm not saying to like use response bias in those surveys, but like for real, rate, like, subscribe, however you want to put it. But no, like give the feedback that is honest. And I also can recognize if there are things that I could have done better, please share. I want to make sure that Thursday is good because Thursday is going to be wild. There's no chat on Thursday because there's going to be over 1,000 people. And so we won't have this level of interaction. What I will say to you is between now and then, okay, if you've been getting the emails from me, you have an email address for me. If you want a little bit more commentary on your possible responses to this, or if you have a couple more follow-up questions, I am more than happy to either respond on email or, as a school teacher, that means I have a Zoom account now because that's apparently what we all have. I'd be happy to schedule short 10 to 15-minute face-to-face meetings with folks if that's something you'd be interested in. Just reply to whatever email I send and request it. But that's only for you guys, not for the 1,000 people that join on Thursday. So it's been a pleasure. It's been great getting to know you guys through the chat feature, and I'll stick around for a few more minutes for folks that have just any follow-up questions or anything you guys want to ask about this. And I cannot wait for the 5-hour cram session, and then we'll try to plan something for after the test to just have a place for us to celebrate. So see you later, and I'll stick around for a few minutes with folks who have questions. All right, so Anna, so a two sample Z interval is when we have, if we're trying to compare the proportion of individuals who give a certain answer from two separate populations. And so the samples should clearly come from those two separate populations. And so in this case, even though in our survey we could break down who's above 55 and who's below 55, that sample all came from the same pool of data, the same 103 people. It was not independently collected samples of young people and old people with an exclusive look towards those two groups, in which case then we could compare the results from those two independent samples. I will say, like, you could make the argument that because the people are different ages, we can treat them independently. I'll admit that the question I was drawing this from, it was very clear that it wasn't a two-way table like this. It was a yes or no. And the scenario was like, could you do a two sample Z-test to compare the difference in yeses versus nos? And it was like, well, no, because they're from the same sample. You can't do that. So this one was a little more tenuous, but Anna, I hope that answered your question. Yeah, perfect. So James, the conditions for any inference procedure. So this is Z-test, T-test, confidence intervals, hypothesis test, one sample, two sample. There's the same baseline conditions. And those three baseline conditions are: the scenario needs to involve randomness. And so randomness can involve random selection, or in the case of an experiment, random assignment. No problem, Dahlia. Random selection or random assignment. The sampling distributions of the sample statistic, so sampling distribution of p hat or sampling distribution of x bar, have to be able to be approximately normal for us to run any calculation. So in the case of confidence intervals, that's margin of error. In the case of hypothesis test, it's to get our Z or T test statistic. All you need to know is, for those sampling distributions to be approximately normal, there are these magic numbers you got to hit. And if you're in a Z scenario, that's categorical variables, the magic number is 10 and 10, 10 successes and 10 failures. As long as you have at least 10 of each, you're good. And so in this scenario, if we're looking at like the second problem, there's that two-way table, and there's 25 people who say yes and 73 who say no, so we're good. At least 10 of each. Those two, you always have to check. You always have to check normal. In the case of a t-test, the normal is coming from at least a sample size of 30. So the 10s I'm mentioning, that's NP, NQ. NP hat, NQ hat, or in the case of, if you already know what P is, NP and NQ. Those both have to be at least 10 to ensure that the sampling distribution is normal, or approximately normal, excuse me, so that you can do appropriate calculations. So we've got random, we've got normal, which is really just making sure the sample's big enough. Then there is a third condition that we sometimes check if there was random sampling. If there was random sampling, we have to ensure that the individuals we gather in our sample could be assumed to be independent of each other in terms of whatever the response will be. And that, because we're sampling without replacement, can't be guaranteed. Because if you think of like scenarios you do with binomial variables, it's like, oh, I've only got 10 names in a hat. As soon as you pick one name out, there's only 9 left. And now the probability of the next success is different because something out of 10 versus something out of 9 has a very different probability. So that condition is met if the population is really, really big and our sample, even though it's big enough, is less than 10% of the overall population size. If you think about like the denominator going from 10,000 to 9,999, the difference in those percentages would be super, super small. And it's as if we could assume that they were the same and we could assume independence. So it all comes down to, can you assume that the population is at least 10 times the size of your sample? And if you can, you're good. If you do an experiment with random assignment, we don't have to worry because there wasn't any selection without replacement. We're good to go. So to recap, you always have to check two things: random condition and the normal condition, which is AKA, some people call it large count or large sample. And 3 is sometimes, if random sampling, you check the 10% condition, sample less than 10% of population. Yep, question 1, part D. So this scenario involved assignment of containers. This was Brandon, that's a pretty good list. It's a sorry, James, I just got distracted. So in this case, when we do random assignment of the containers, now each treatment group is independent of the other treatment groups because we've assigned the containers to their groups and they are all separate now. So we don't have to worry about the eggs coming from a random sample or not, because the thing we're trying to compare, the different treatments, have been randomly set up by us, and those groups, by being set up by us, can now be considered to be independent groups of eggs because they're under different conditions the whole time. So those 3 treatment groups now count as independent groups when we're doing the comparison at the end. So I know that's a mouthful. The way to reduce it all to what you need to take with you is, if the randomness comes from an experiment, you don't have to check the 10% condition. Yeah. So if we were going to do a hypothesis test for question 2, okay, let's say we were going to see, is the proportion of people who support this at least 30% or at least 20% or whatever? In that case, there was no random assignment. The randomness is coming from the random selection of people. So the random sample, check the randomness. The normal condition, check because our successes and failures are both at least 10. But then to meet the independence condition for our 1 sample test or even a 2 sample test, we would have to show that the 103 people we picked represent less than 10% of all people we could have picked. So we do 103 times 10 is 1,030. And 1,030 is reasonably assumed to be less than the size of all people in a large city. The people aren't independent, so it's, yeah, and now I'm getting into we're going to kind of keep spinning our wheels here. By the way, Lydia, I've not forgotten about you. So if you're still here, I'm going to get to you in just a moment here. I think she might have left though. Whoops, sorry. In the population, there are a certain number of people who are going to say yes and a certain number of people who are going to say no. Okay, and so if we pretend there's only 20 people that we can ask, a certain number of them will say yes and a certain number will say no. So if we go in and sample some of them, okay, as soon as I pick someone who is going to say yes, I'm now less likely to pick a second person who's going to say yes. And if both of the first 2 people say yes, I'm now even less likely to get the third person who's going to say yes, because, in the population, there are some that will say yes and some that will say no. So when we sample without replacement, our individuals in the sample are never really truly independent in terms of what it means to be independent in statistics. Yeah, this is only for no replacement. Of course, if we do replacement, then we could get anyone anytime. If they're doing replacement, you're automatically independent. I've never seen a scenario that involves sampling with replacement when you have to check conditions. Okay, cool. And so yeah, that's all good. No, not to worry. Hey, it's why we're here. I'm also definitely like the kind of person who's like, I'm not going to stop until. So really the only difference, so to speak, is you now have to check everything for both samples. So the random condition, you got to show both samples are random. The normal condition, you got to show both samples meet the criteria for the magic number. And if both samples were done without replacement, you'd have to check that both of them are less than 10% of their population that you would generalize to. So it's not any new conditions. It's just you got to check it for both groups. And then if both groups meet, you're good to go. Yeah, fabulous. There was a question earlier about, yeah, no problem. There was a question earlier about interpreting p-values. Does anybody here still need an explanation on that? I also would, okay, cool, yes, I'm here. Okay, so you know what to do with p-values, right? Like you know when to say reject or not reject your HO. Okay, your question is like, what the heck is a p-value? Okay, what a p-value is, the headline is the p-value is the probability that, how do I put this? So first draft, the headline is the p-value is the probability that the null hypothesis is telling the truth. And so that's why when p-value is low, we reject the null hypothesis, because if that probability is low, then you're like, there's only a 1% chance that you're telling the truth, get out of here. The more nuanced answer is when we do a hypothesis test, we set up our hypotheses first. And so we go into everything that we do by trusting the null hypothesis. So let's say we're going to do, I'll just try to give like really concrete example here, one sample Z test where the null hypothesis is that P is 0.5 and our alternative is no, P is actually greater than 0.5. When we go to look at so we've named the hypotheses, we've checked the conditions, everything checks out. When we go to look at our sample result, let's say we asked 100 people a question and our p-hat was that we got 55 out of 100 to say yes. So our p-hat is 55 out of 100 is 0.55. Okay. So our sample result is higher than what the null hypothesis said. But as we know from the whole year, sample to sample, our results might be different. Randomness happens, variance happens, things happen. So the question then becomes, is that p-hat far enough away from what the null hypothesis said would happen to where we would doubt that the null hypothesis is telling the truth? And so what we would do in a hypothesis test is we would say, well, okay, let's assume the null hypothesis is true. And let me now think about what's the probability that I would actually get this sample result in a world where the null hypothesis is correct and my p-hat should be 0.50. I actually got 0.55, but I should have gotten 0.50. And so to answer that, you'd have to sketch a normal distribution where you put 0.5 in the middle, and then your standard error, what you count by, you would calculate based on the standard error formulas that you find on your formula sheet. And we do square root of 0.5, 1 minus 0.5, all over 100. We'd work it through. In this case, I think that would be, actually I can tell you, I think it's 0.04. And it's really sad that I've done this enough times that I know that, but let's find out if I'm right. No, it's 0.05. Okay, I was close. Okay, so it turns out that if the null hypothesis is true, then getting a p-hat of 0.55 when we take 100 people for a sample, that p-hat is one standard error above the mean. Okay, so our Z test statistic would be +1. We are one deviation away from where we should be based on the null hypothesis being true. And then we'd ask ourselves, okay, well, how likely is that to happen? We would go look at a Z-score table or use our calculator and find the probability that our sample result was that big or bigger. And because this is a Z-score of exactly 1, I happen to know that that probability is about 0.1584. And this that I just found that probability is a p-value. And so it is the probability that I would get a sample result that is as big as the one I got, or as small as the one I got if it was a less than sign, or as far away as the one I got if it's a not equal to sign, assuming that the null hypothesis is true. I'm going to pause for a second because I just did almost like 4 straight minutes of talking. And I know that this might be kind of hard to picture because I'm doing it all words, no visuals. So Bella, how are you feeling at the moment? Okay, cool. And apologies if I went a little too slow on that, but it even helps me to kind of try to break it down and explain it. So you're going to find in a lot of like cramming documents and like study session stuff that there will be a document with a template, and the template will say something like the probability of observing a sample result as extreme as the one observed given the null hypothesis is true. That's what we just described. So in the case of the question tonight, it was the probability of observing a difference in ratings as big as the difference we observed, assuming there was no difference in the ratings. Yes, you have to assume the null hypothesis is true, and you have to mention that. In tonight's, so where was it? Just being like the probability of getting a mean difference in ratings as big as the one we saw is 0.0137. No, it's the difference being that big, assuming that there is no difference. Okay, because if there is a difference, then we'd be way more likely to get that sample result. The p-value is only being calculated from the null hypothesis being true, from the sampling distribution we would draw under that circumstance, and then from the calculations that we do off of that. So yes, have to mention that this is based on the null hypothesis being true. Whew. Yeah. All right. Last call, because it's almost 11. This is about to be a big old file I got to upload. All right, everyone. All right, y'all. Well, I will see you there on Thursday. I look forward to it, and I'm so excited for you for Friday. It's gonna be fun. So take care, and see you guys for the second half of the stream on Thursday.